Welcome back to another video of changing bases. We're going to continue on with the examples. So again, this is the same thing as the previous video. We have to find B prime, or the change of bases from B to B prime. So we can get straight into it. And we're going to be using the much more shorter method because it's shorter and pretty much the same thing as the other ones. So again, we have to figure out what side goes where. And so, like I mentioned, we have B prime, then B. So B prime will be on the left side. And 6, 0, 12. And then our B is going to be looking into the right side. So now all we have to do is just put the inverse on one side, and then on the right side will give us the translator. So lucky us, we have a pivot, so we don't really gotta do much with the first row. So what we can do is probably divide. Yeah, we can divide the second and third row by, well, the second one by 2, the third row by, this is supposed to be a 12. The third row by 4. So we are left with 1, 0, 6, 0, 1, 0, 0, 8, 2, 3. And this is supposed to be a 1. Be 1, 0, 0, 0, 1/2, 0, 0, 0, 1/4. Alright, cool. So now we can get rid of this 2. So we'll be having 1, 0, 0, 6, 1, 0. Then this would be 0. This would be 3. Ooh, lucky us, we got a 0 on top. So first 2 remain the same. And then this one it'll be twice negative. So that'll be -1. This would be 1/4 again because of the 0. Lucky us. And so now we can get rid of this. Actually, we can't. Let's not get rid of this 3. Let's get rid of this 6. So the bottom stays the same. 0, 1, 0. Then this would be 1, 0, because it's 3. And this would be 0. So -1, 1/4, 0, 1/2, 0. So it'll be 0 and 1. So that'll be 1. And then it will be twice or negative twice. So it'll be 2. And then again, it'll be negative twice. So twice of 1/4 is 1/2. And it'll be negative. So -1/2. And then now we can divide by 3 on the last one. So we'll be given, or we'll finish off with our identity on the left side with our change of bases on the right side. -1/3, and this would be 1/12. And so our change of bases from B to B prime simply gonna equal to zeros. These are supposed to be zeros. 1, 0, 0, 2, -1/2, 1/2, 0, -1/3, and 1/12. And that was like very simple. Now there's one thing to point out. Some of you may have noticed, some of you may not, but if we looked at the example, or not the example, the starting position, this low key, high key looks very familiar, because even though we had our B prime and B, this looks like some matrix A and its inverse. And now we finish it off with the inverse here. And when we usually take the inverse of a matrix, the right side is just the inverse. So what we can say here is, if you're going from B prime to B, where B is the standard basis, well, we can just say that our translator here is just equal to the inverse of B prime. And this will only be true if you're going from standard bases to some other bases. So from here we went from the standard bases to, or which was our B, to our B prime, which is not in standard bases. And so we still have to do the same process, but it's very interesting when it becomes, especially like 2x2 matrices, you don't really have to do all that augmented stuff. All you could just do is the inverse would be like AD minus BC. It's 1 over. And then this would be DA negative C negative B. You should do that. So much simpler. So that is something interesting to point out, and it's something that you can just keep in mind when you're going from standard basis to any basis. So now we're just gonna go ahead and do one more example. This would be a little bit more difficult because we're using two non-standard bases. So let's get right to it. So our last one, we are given two bases, and again it's the same it's the same thing. We are going from B to B prime, and so we have our B prime, so it's going to be on the left side of the augmented matrix, it's going to be on the right side. So it's going to be on our right side, and so let's just get right to it. So it's going to be 1, 1, negative 1, 0, 1, 2, negative 1, 4, 0, 3, 2, 1, 1, 1, 2, 1, 2, 0, and all we got to do is put this in the inverse on the left side, and our answer is going to be on the right side. So let's start off with getting rid of this negative 1. So it'll be 1, 0, negative 1, 1, 4, 0, 2, negative 1. Then this would be, first two remain the same, and then you add them together, so it'll be 4, 3, 1. I wonder if I can fit this here. So now we're gonna get rid of these other one. Other one. Okay. Okay, I saw other. Okay. 3, 1, 1, and then 4, 3, 1. Okay, we have 0, so this would be 1. And then it will be negative 1, so we're adding, because we're subtracting, it'll be 5. Then subtracting, this would be negative 1, and then be 1 minus 1 is 0, and then 5 minus, no, not 5, where did I get 5? 2, 2 minus 1 is 1. So now we got rid of that. Now we can get rid of this 2, get rid of this one. Okay, 1, 0, 0, 0, 1, 5. First 2, so base remains the same. Negative 1. Well, it's not as always, but you get the idea. This would be 0, and then this would be multiplied by negative. Oh, this is 5. We're working with 5. Okay, negative 2. So this would be negative 10 minus 1 is negative 11. Then this would be negative 1 times, what's it, 2? Wait, negative 1 times 2 Oh, -2. Whoops. And that'll be 2. So 2 plus 4 is 6. We got a 0, so this will remain the same. And this would be 2 times negative, or -2 times 1, which would be -2, plus 1 would be -1. Alright, we're getting somewhere. Looking kind of icky though because of this 11. Because now we have to divide. Yikes. So 1, 0, -1, 0, 1, 5, and 0, 0. Should I keep the negative? No, I'm not. This is gonna be 3, 1, 1, -1, 0, 1. And then we got 6 over 11, -3 over 11, and then 1 over 11. Ew. Fractions. So now we can get rid of, oh, we could get rid of this -1. Just simply adding. How lovely. This would be 0, 0, 1. And then, of course, now this time the bottom two will remain the same. -1, 0, 1. So we have, oof. Okay, so 3 minus 6 over 11. So 3 is 33. So 33 minus 6, it will be 27 over 11. Then this would be 1 minus 3. So this would be 11 minus 3. 11 minus 3 is 2. 8. 8 over 11. And then we'll have 1 plus... 1 plus 1 over 11. So it's just 12 over 11. Cool. How lovely. Don't like the fractions, but so far is... they're being nice. So lastly, we just gotta get rid of this 5 that I already got rid of by accident. Alright. Get rid of this 5. Just divide minus 5. Minus 5. So now we're gonna have our answer, our identity on the right side. And our answer on the left side. So, well, at least we don't have to work with fractions on fractions. It'll be 12 over 11. The bottom one will be -6 over 11. -3 over 11. And then 1 over 11. So now we have multiplied by 5. We'll have negative 5. So we'll have 30 minus 1. So 30 minus 11 will be not negative, it will be 19. Oh, that's cool. We have 0 on this one. So let's just be negative, positive. So 3 times 5 is 15 over 11. Ooh, I like that. And then lastly, we have, we have another one. Okay. And then we'll multiply by -5. And so that'll be 5 plus, no, 1 minus 5 over 11, so that'll be 11 minus 5, which would be 6 over 11. We have our identity, we have our change of bases. Oh my gosh. Our answer, which is kind of whack because of the fractions, but that's fine. They played nice. It wasn't fractions on fractions. Our answer is going to be 27 over 11, 8 over 11, or a change of bases. 19 over 11, 15 over 11, 6 over 11. I should realize I could have done something else that'll make this so much prettier. That looks like a pie. Or you could just factor out the 1 over 11 and just have 27, 8, 12, 19, 15, 6, -6, -3, and 1. Wow. That was easy. So that concludes, I believe. Yeah, I think that it does. That concludes all of change of bases for these examples. We are now going to be progressing towards the rank nullity theorem, and it's only going to be just 3 examples. Mostly because they're like fairly easy to do. Like once when you get how to do one of them, it's just rinse and repeat. But yeah, I'll see you guys in the next video.